Carole Bourlon. I work for Bretagne Développement Innovation, it's the regional development agency for Brittany, and I am responsible for Eurolarge Innovation. It's the support program for companies in the technological sector for Britain ocean racing. This is known as Bretagne Sailing Valley. It's an industrial sector of 210 companies, 1,000 people, and about 85 million euros of annual turnover. There are 200 racing teams in Brittany, and especially in ocean racing, on large boats such as the Ultime Trimarans, the Imoca monohulls, and a lot of other supports here in our region. So this sector has arms everywhere, including in the America's Cup, and that's what we're going to be talking about this morning. And before we start, here's a few tips for using Zoom. So at the bottom of your screen, there's an interpretation tab where you can choose to listen in French or in English. Also, you have a tab for questions and answers where you can send us your questions concerning the theme of today. Please just ask your questions there. And then for anything else, you can use the chat. So I'm going to start the video conference. So this morning, we're going to be talking about the technical assessment of the America's Cup. The 36th edition finished the 17th of March last with the win by Emirates Team New Zealand. And for the first time, they were sailing on the AC75. So now it's time to look back and have a look at the technical assessment and think about the technological developments. And with us this morning, we have three experts from the design teams. We are delighted to welcome, first of all, DIMITRI Despieres, who's an engineer, member of the design team American Magic. Hello, Pierre. Welcome, and thank you for being with us this morning. Also, we have the naval architect, Guillaume Verdier, member of the Emirates Team New Zealand. Hello, Guillaume. It's a long time you haven't participated in any of our conferences at Eurolarge, and we talked a lot about you in the Vendée Globe, but over the last few months, but we're delighted to welcome you here today to talk about the America's Cup, another one of your specialities. And finally, to complete the panel, we have Gautier Sergent, who's general manager of the company North Sails France, based in Vannes in Brittany. And you were a member of the Ineos Team UK design team. Hello, Gautier. Thanks for being with us. So this roundtable is going to be moderated by Pierre-Yves Lautroux. Hello, Pierre-Yves, over to you. Thank you. Thank you, Carole. Thank you, everyone, for being here. I just want to tell you that you can ask any questions at any time in the Q&A tab at the bottom of the screen. And that's where you need to ask your questions. So we're talking about the technology of the America's Cup. So we're going to try and stay within our experts. So what's very interesting is we have specialists in three specific strategic domains of the America's Cup: the hull and the appendages, and the rigging and the sails. So there's a couple who are in Auckland, 7:30 in the evening. Guillaume Verdier and DIMITRI Despieres are still in New Zealand. And Gautier is in daytime in Vannes. And Gautier is off to sail on Banque Populaire 11. And he's put off his sail so he can be with us. So a general question for you this morning, because we had a new design this year with a new boat. So I'd like to ask each of you in your turn, how could you characterize the America's Cup this year? There are innovations obviously every year and changes, but how did this edition go in terms of innovation in the America's Cup? Did we cross a line? Did we can you describe to us in the big picture? Let's start with Dimitri. Member of the American Magic team. So I saw it nearly sink at the end. So for those of you who followed, but no, for the big picture and to be more serious, I saw it as a success. The success of a design that a lot of people decried at the beginning, and we thought it was when we were reading the class rules, we were thinking that it was going to be difficult to have races that would be tight between the various teams. But in fact, the rules proved the contrary, because we had a really tight race. It was a success from a technological point of view, but also from a spectator's point of view, from the show. And that's a sort of a big picture view of the America's Cup, as I see it. When we got the class rules at the beginning, we were quite surprised. Not surprised, but we were expecting something quite extraordinary, and it was. Gautier?
Vous en avez tous fait plusieurs, hein?
You've already done several editions of the America's Cup, but I agree with Dimitri. The class rules was very ambitious, and we were all a little bit hesitant, but the America's Cup played its role. It was inaccessible from a certain point of view, from practically, technologically. It seems very far away from the normal sailing practices, but that's what the America's Cup symbolizes, innovation at the highest level. It was a race of sailors and technology, and for me, that's the definition of the America's Cup. I think it actually found its soul again. Guillaume, you're in the team that defined the rules of the game. Can you tell us if, in terms of the class rules, if the boat you designed, if it met your expectations in terms of the spectators, the show, we think, and in terms of the design? Yes, we're happy that we proposed this concept. I'm talking of all of the people in the Team New Zealand. I'm only one element in a big team, and I only work part-time because I have a lot of other things, but we proposed this concept originally for a 40-foot for a client of mine. It didn't happen, and in fact we proposed the concept to Grant Dalton. So we did some tests for a couple of months on the simulator to see if it worked. I thought it worked 50% better than an IMOCA at the beginning, because there's no keel. We put lead in the foils to be more dynamic and to stabilize the boat starting. And then in the simulator, it worked well, but it worked even better than we thought. And we progressed so much that we were quite surprised of the performance upwind. It was quite limited, like in the AC50s. We'll talk about maybe later, but the performances upwind really surprised us. As Gautier was saying earlier, the dream of the America's Cup for sailors is the AC5, because there was real match racing then. When we make boats that go fast, it's not really match racing anymore. We weren't sure that it was going to work, but it really, with good and bad tactics in terms of the crossing, and I was afraid of accidents because that's something in this type of boats, they are dangerous if they're not controlled correctly. That was my major fear, but in fact, it worked well. And we were lucky to be doing it in New Zealand, where there are no hills and where there are lots of hills and there's no COVID, sorry, and we were able to not have masks. So with new class rules and a new boat, were you expecting the competition to be so tight? That's the big surprise, in fact, and the effectiveness of the innovation in the sport. Yes, I think we were expecting the competition to be tight, but we didn't know how each one would be progressing. But we saw that with different levels, it all came together very well, and that it was really.
Qu'est-ce qui a été le plus compliqué techniquement?
What was the most complicated technically to put in place from the outside? This is one of the characteristics of the America's Cup. From the outside, you don't see an awful lot. The boats are fully equipped. We see heads come out and the boats are clean and finished, and we don't really see what's happening underneath. But purely technically, what was the most complicated thing to get right? The control of the boat at 50 knots? Was it the ability of the systems to react quickly and effectively? We see tacks, the foils going up and down with no problem. What was the biggest technical challenge? I think it was the foils, really, because we did foils with flaps, which was really cool. But the mechanisms of the foils to have a good flow was really quite complicated. And from the point of view of the rigging, Gautier will talk about it, but there was an infinite number of complex solutions. I think there are a lot of solutions that work, and we just took one that worked, but there are lots of others. To find a balance, once you go down a path, you have to go to the end. Gautier, so from your point of view, as a boat designer, what was the biggest technical challenge? We didn't really talk a lot about it, but the class rules were quite strict. Yes, the mast was partially one design. People don't necessarily realize, but there was a structural and shape was fixed. And like Guillaume said, it opened a lot of solutions up. And then the complexity was to find a balance. That's the sort of a hybrid between a sail and a wing, and we had to find the right balance between the complexity of a wing and the precision of control and the simplicity of a sail and a reasonable weight. So we had constraints of center of gravity and weight. We're starting from a blank page, in fact, with a double skin sail for the mainsail. And we had to find the right balance between putting a lot of control on control systems, which are complicated and sometimes which compromise reliability because they're heavy, and to have enough control on a traditional sail that enabled these boats to go from something unstable where the foils are not active to completely flying where there's too much power and we have to try and slacken the sails and lower the draft. Because you're going from a world from wings that you can move as you want with a lot of possible trims, to a world where with the double skin sailed, where you completely change the way it works, in fact. Yeah, it depends on the culture of the team, in fact. We can have either a wing, a simplified wing from a sail. We say we just do like a sail that's are more sophisticated. Like Guillaume said, there were several possible avenues, but we chose the avenue of a sophisticated sail. With Ineos, we went on for a concept that was a simplified wing. So it all comes together, in fact. But there's so many possibilities, in fact. What is really complex, it involves everything. It's not just a wing. There's the mast of the boat, there's the total mass of the boat, the aerodynamic, hydrodynamic balance. We saw that in the junction between the sails and the deck, and not forgetting the front, the foresails, with traditional controls and loads that are huge, in fact, with a limited weight. So that we had to work on the structure of the sails, on the material, which is invisible for the naked eye, but it's very intense. And I think it had an effect on traditional racing, but also on more traditional boats. Yes, we'll come back to what it means for other sectors. Dimitri, at your level, you're responsible for systems in American Magic, which is quite a big job, but what were the main challenges that you had to face in terms of innovation? I was managing all of the systems in general, but I also had a specific task, which was to, as Guillaume said, the new foils which had flaps. And I was partly responsible for the designing the control system for the flaps. So it's very interesting to see that ultimately, for solutions which are quite different between the teams, we managed to end up with boats that could sail in similar speeds in the same conditions. So that's quite important. As Guillaume said, there's not just one system or one solution that works. If we develop it correctly, there's a potential to play on the same playing field. In Team New Zealand did a bit of a demonstration, in fact, at the end, but for you, the most complex thing to manage was the flap system. Is that right? I don't think for the American Magic, I don't think we did a very necessarily excellent work in the rigging and sails, especially in terms of systems. But in terms of the foils, that was the challenge. It's not just the challenge of the system. It says we're always going to find a way to control the surface. But as Guillaume was saying, there's the challenge of not doing something that's very clean to avoid cavitation, and do packaging. So we don't just have to do an efficient system that's going to respond in a few milliseconds to the sailors for boat stability during flying, but more than that, there's also getting all these systems into the smallest envelope possible to reduce drag that these appendages cause. So there was a challenge in terms of the whole design to know exactly what can we do with these appendages and not wanting to do too much, because the system would take too much place if we wanted to do too many things, in fact. So there were choices that had to be made, different choices made by the teams. And I think really interesting.
Guillaume, quel bilan tu tires toi
Guillaume, what is your view of the race technically for Team New Zealand? More than the victory, obviously, it was not your first participation, but what technical lessons have you learned from the methods and the materials and the equipment? How would you sum up? Every time I'm quite surprised, actually, by the complexity of the systems, managing to get a machine that works with so much electronics and mechanics inside and working on the first try almost on boats like Gipana and Bank Popular. They managed to get them working, but it takes time, a year, 2 years. Here, you have to realize that we were 150 in the team, and they're working in 3 shifts. When the boat comes in, they work all night, for example, if they have to do. So there's a huge complexity of the systems, and I'm really very admirative of the people who deal with these systems. All of the electronics behind it, because there's all the software. It's managing to get not just the architecture of the boat, it's the architecture of the connection of all of the skills of all of these parts that ends up by make like a piece of music, in fact, that comes out with not a single bad note. There were some bad notes, but as we play the piece, I'm not a musician, but you can see that we're doing like music on a piano if there's a bad note, but you realize that we really did it cleanly. It's almost really at the last minute, and as we get better and better with the piece of music, so it's almost perfect, we change the foils and we multiply the risks. If it was a rocket, I wouldn't get in it. That would be mad. We changed the foils 1 week later. We're in a race. We hope for a perfect performance, but people have to be really careful. There's a lot of procedures, of course, that are there to prevent people to go on board, and there's not a screw that's removed without it being traced. So it's really also in terms of software, we're all a little bit afraid sometimes, and there are really meticulous people in the team. Martin McKelvey, for example, who follows the life of the boat when it starts racing, and who traces every change. And for the mass of the boat, which was a really strict criteria in the rules, I think it's a little bit too strict. I think it's quite incredible that we managed to race every day despite this. Have you seen the team? Has the team changed from one edition to the next? The team has changed the way it's worked, its architecture between 2 races. In Team New Zealand, has the team changed a lot, in fact, from one edition to the next, in terms of design and technicality, and that's one of the strength of the Kiwis, is to be able to is their performance and to be able to adapt over the years. In fact, I think they were more used to having smaller teams, in fact, and now we're almost too big, the team now, and there's a part of luck that happens that it works, and there's quite a risk when the team gets bigger. We say that the complexity it's the square root of the number of people involved. So one more person, it's one, but 2 people, it's multiplied by 1.4, the complexity, etc. So I was quite afraid of the size of the team, and people have to get on well. Perhaps I would say that the first actor in this team like this is a psychologist who has to make sure that people get on well, and that, you know, to keep the team well oiled, because just the slightest little bit of gravel in a team like this is dramatic. So there were no psychologists in Team New Zealand. You know, it worked well. Yes, it really worked well.
Gauthier, c'était comment chez Ineos Team UK?
How was it for Ineos Team UK? What lessons did you learn technically from this? The boat worked very well, that it didn't work so well. There were ups and downs. I'd like to come back to what Guillaume said, is sailing in general is doesn't have many standards and regulations. So it means we push the use of materials and structures and systems and electronics very far. Like Guillaume said, if it was a plane or a rocket, it would never get developed so quickly. We can often see that with Formula One teams, for example, who try to contribute to they're used to development cycles that are 50, 20 years. So for us, it's been 3 years. So we start from a completely brand new concept that nobody's worked on before. It's a huge challenge and a bit of a miracle, actually, that it worked. In terms of the lessons, technological lessons learned, I think that, as I was saying earlier, it's really very rich, because we put innovation back into the America's Cup, and that's the role of the Cup, I think. We throw a boat into the water much further than we know how to swim, and then we start swimming to the boat, hoping that we can swim a little bit better as far as, you know, as we go on. But in fact, it's the human resources that we manage to go beyond beyond our limits. When we think we've reached our limits, I think we're only at 3/4 of what we can do, and that's from the technological and human point of view. We're all exhausted, but at least the America's Cup was incredible. From a technological point of view, what concerns me more specifically in terms of the sails and the rigging, there was many lessons learned. We pushed the structure of the sail very far in terms of weight constraints and loads. We had to develop high power at low speeds to get the boat up in the air, and to be able to make use of this power, either with the control systems, traditional control systems, for example, you know, the Cunningham, the sail trimming. It's still sailing, but in terms of lessons, we pushed these concepts we really far. And with this double skin sail, you can't imagine what's inside it, and we haven't seen what the competition has done. So there's a degree of complexity there as well that was really a great success. It could really be good. I mean, there could have been a disaster, but I was talking to the head of sales in Team New Zealand, and he said in English, "We got away with murder." That means that it could have been a disaster. They had certain criteria in the rules based on initial calculations and simulators, and there's some good faith and guessing. But now that we look back, was a challenge, and things that we'd have to change definitely in the new rules. And maybe they're just details for the public, but there are things that really caused us a great headaches. And my hair didn't grow back in this edition. Dimitri, like Gautier, complexity and intensity in American Magic. Complexity, yes, I'm a bit in two minds. I don't talk about complexity, but I talk about difficulty, yes. It's not always the most complex things that are going to work well. It's usually the opposite. Simple things work better. The complexity sometimes are things don't understand because we haven't looked at them, or they're not experts in the sector. And in the same way that we're not necessarily going to understand things in their sector. Once that we have sort of examined and understood and explained things, the complexity, we live with it every day. For us, we don't really see it as something complex. The boats, yes, are complicated. They require a lot of maintenance, a lot of people. The human factor is really important. To come back to what Guillaume and Gautier were saying, what I find extraordinary in the America's Cup is that this human factor is very present still, and it makes personally, if I bring an idea to the table and I'm only on my own, it might be a good idea, but it's with the teams in the America's Cup that with groups and different cultures, because the teams are comprised of people from many international horizons and different cultures, we still manage to bring things to the table with a maturity which is exceptional. And I think that that's, from a technical point of view, I think this emulation that is in the team is really extraordinary and very interesting. In general, technically also, like we said, the boats are extraordinary. I appreciate a lot to participate in this first monohull 75 flying boat, and the class rules. But we hope that the little things that need to be adjusted for the next edition, and we'll see even more interesting matches. Maybe we'll talk about it. But Guillaume said that we've seen match racing. We saw more than match racing, in fact, because we didn't anticipate that. So that was incredible from that point of view. The lessons learned for you from American Magic, without turning the knife in the wound was a very strong experience, I imagine. Yes. So the boat turned over, it had to be repaired. It was really complicated. That's just a detail. That was almost planned. Yes, no, the capsize, it really brought the campaign, American Magic campaign, to a complete standstill. It's always fun to hear Guillaume talk about they were a little bit afraid of us. I don't think they were afraid too long, but at least it was a campaign that was really intense, like it was for all of the teams, obviously. But once again, to have experienced all of the campaigns since 2000, this one had something really joyful, which was to have these new class rules and to bring something new in terms of systems. It was a real challenge, and to try and get around the rules in some places. And personally, or lessons for me or the group I'm not the only one to be working on the systems, of course, but it's to have managed to appreciate working with all these people already, and to have developed new systems which can be used elsewhere than the America's Cup. That's we see it a lot in terms of the America's Cup. It's a recognition of what the America's Cup brings. I'm going into details, but there's interaction between other groups. For example, a tool that developed a lot, we'll talk about it maybe is the simulator. And that takes more and more space, in fact, with the integration of, maybe we'll talk about integration, but between these different groups, the systems that have tried to integrate as best into the simulator to be able to give more accuracy and more anticipation as to what the real boat would be like several months later on the water. Even for a second boat, it was an important. We're going to talk about this with you. So for you, what is the major innovation for you that in this America's Cup? Or is it the confirmation of a tool like the simulator, or was there really was it really an innovation that marked this edition of the America's Cup? I can only talk about what I saw in American Magic, but internally, Team New Zealand did a bigger step than us last time in the Bermudas. We tried to catch up the simulator. It's true that it's a tool that showed its ability to save time in terms of the design, but also it enabled a lot of teams to talk to each other because it had to integrate a lot of information into the simulator. We're talking about VPP, CFD, all of these. We'll talk about what these are, but we're talking about systems, aero models. All of this has to feed the simulator to get something accurate. Otherwise, we get wrong information. If you put wrong information in, you get wrong information out. So that is already that in terms of the design. But then there's also the use of the tool by the sailors and by the coach, and all of this we probably didn't do enough, in fact, in terms of American Magic. But in the evolution of the campaign, for example, that over the last 3 editions, that there is really an increasing importance of this tool, which is important, in probably the biggest evolution that I've seen, yes. With systems that take part of this, but that's because of the design rules. The design rules mean that we're opening up the capacity to make the boats fly and control them. So there is the role of the systems plays an increasingly large part because we're making boats fly. We could reduce this part. It's just in the design rules. Guillaume, for you also, is it the importance of the simulators that marked this America's Cup edition? For us, it was more the previous edition. The foils, we need to remind you that TMZ was in advance in terms of the other teams, in terms of using the simulator. Yes, there's several ways of using these tools. We can work with derivatives, knowing, for example, the weight of a modification, the weight of changing a trim, and then work obsessively on a saffron, for example, on a rudder, obsessively on the foil to limit cavitation and know what is the price of the derivative and how much it costs. What is the price of cavitation on speed, for example. And once we know that price, we work hard on it. And I would say that more than the simulator, we have to have good simulation tools. In this edition, we weren't allowed to do hydrodynamic tunnel tests on the hull. It wasn't accepted in the design because in an aerodynamic tunnel, for example, it was a very high cost. But we would have learned a lot of things if we'd been able to do that. We see a lot. There's a lot of things we see in the simulator and CFD, and we have to see also what happens on the water. I was quite surprised in this edition with the data acquisition, the quality of data acquisition, and have a look underwater, for example. All the teams have done that, to have cameras that look under the water and see exactly the difference between what we imagined and the reality. Specifically, we were talking about the flaps, for example, earlier on the foils, and there's mad things that happen under the water. The teams that had good data acquisition will probably progress faster. They all did. Everybody was looking, but we had. We're able to really, we were really happy to have really good pictures that we had photos of our competitors also that were really great. But all of that to say that the reality of the marine environment is really very complex. What is the calculating power necessary for the simulator, the processing power? Simulator on a PC. We can work on a PC. In terms of precision, we don't have to have huge. We have a big processor. Honestly, I don't know what the processor.
J'ai pas la réponse à ce chiffre. C'est un gros ordinateur de calcul qu'on a qui nous était passé par HP. Donc,
we had an HP computer. Gautier, another connection, another question. You can tell us about the role of the simulators.
Oui, est-ce que le concept de grand voile à double pot a fait ses preuves? Et est-ce que
Did the double skin sail concept work, and is it better than a wing? That's a really hard question to answer because we didn't have the choice. We made this double skin concept worked as best we could. That was already a big challenge. And we didn't have a lot of time to compare what a wing would have been. We know that in terms of the aerodynamic coefficients that we're able to generate in terms of power and the range of power specifically. To answer that question is really difficult. The concept worked because the boats sailed at speeds that were very high. I think that if there was a wing on the boat, it would be completely different. We'd have to change a lot of things. The loads would be different. The weight would be different. The sail plan would be different. We wouldn't have necessarily the same front foresails. It's difficult to answer the question like that. It worked, yes. Did it work much better? We have to put a lot of things in the equation, and there's the financial, technical, logistics. Team New Zealand's desire at the beginning originally was to reduce the need for logistics around the wing in terms of handling. But we dismantled the mast every day. Yeah? We had to have a lot of handling. We had to have the teams to do that, to questions of handling and maintenance and use. And the desire also to move towards more a practice of everyday people with flexible sails. In the design, we had to be able to trim the sail without necessarily sending someone up the mast to the same to drop the sail. Did it work? Yes. Is it better than a wing? Well, we don't have the answer to that question. We haven't really looked at that. In terms of it fulfilled its role. Will it remain? Probably. I think there's only a first phase, so there's an awful lot of development to do still. We've converged onto a solution. Maybe there will be other radically different solutions that will emerge in the next edition. I think that we have to give ourselves a little bit of time before we can really judge the application of this double skin sail for normal sailors. I don't think it has much interest. I'm not saying that in a few years it won't be something that's more common. We don't know yet. Dimitri, a question from the audience. Does the industry give enough standard technical solutions, actuators, electronics, or do you have to develop your own products? And if so, which ones? No, there are things which are very custom made because they are adapted, whether it be the actuator strokes or the dimension, their capacity in terms of load bearing. That's going to be something that we develop or that we build to our own specifications internally. Or we give our specifications out, but that's, yes, these are things that are custom made. However, in terms of valves, control valves and things like that, or all the tubes, we weren't allowed to have titanium tubes, for example, but hydraulic tubes, for example, we don't build them ourselves, obviously. So this is custom for installation, but not for manufacturing. And then for all of the valves, as far as I know, for us, we use standard equipment that was customized internally, but most of the time we used a standard equipment, not necessarily from the marine sector. We don't necessarily go to suppliers that are working in the marine environment, but we can find in all the control systems, for example, systems that come from aerospace, for example, or even from standard industry, because the costs are much lower. But we will possibly be making them work outside their normal operating conditions, because as Gautier said, we take more risks. We're the only ones to put a stamp, an authorization stamp to be able to use certain valves at different pressures than which they've been designed for. And it's we, the engineers, that will put them on test benches and test them. And if we're satisfied with the results, then we will put them on board. So to answer the question, yes, of course, there are things that we don't change, like, for example, the computers, the programming is done internally, everything that's concerning control. But if it's Bake-Off or BNR or there are things that are available on the market and that are used for automation. Automation. Those things, we'll find them on an English production line, the same elements, but adapted. We'll use the elements in the boat. There are also computers which are completely custom made. The mini nodes, for example, that are going to be much lighter, because we always have this problem of weight. And we're going to go and get components or elements that don't necessarily exist on the market, that we will make even just little electronic terminals or boards that will meet a specific need for the control system. So yes, there are a lot of things in terms of human interfaces where it looks a little bit like Game Boy type things. The interfaces that are used for games, we make them entirely watertight, and so we're going to develop our own interfaces with 3D printing, for example, and joints, seals. So there's a mix of custom-made equipment and components that are entirely industrial. Another question of the audience. You're sponsored by, you have a partnership with Airbus, American Magic. How did Airbus work in the design? They were present in a lot of, in almost all of the departments, really present in the systems with me. Laurent Chatillon, Laurent Yes are people that were part of the team. So for me, these people looked after everything that were testing, for example, development of models, of systems that I designed with other people, to integrate them into the simulator also. And there were people that helped in developing the American Magic Simulator with Joseph Rosanne, who was responsible the French side. And they were also very involved in the design of the foils and the flaps, be it for the CFD, the computational fluid dynamics that Guillaume mentioned earlier. These are the flows that we weren't allowed to do in a test basin or a wind tunnel, so we had to do it on the computer. They were involved in that, and they were even involved in managerial decisions in terms of the design team. So they really were full stakeholders in the team, and more involved even than they were than in Team USA, for example, in 2017. Guillaume, a question from an English person about a French challenge. So you see that you talk about the teams growing and getting bigger, and it's difficult to get everyone working together in terms of the design team. Do you think that less is more, as we say in English, in terms of the design? Is it possible to have a campaign with a small team? And in this case, do you think that it could be possible for a French team to put an innovative design forward? There's a limit to everything. I did the America's Cup with Arriva, a challenge. We were a tiny team. It was great. That's where we had learned the most. In fact, when we had a really small team, it's a bit small though. We weren't able really to go into every direction. There is a limit that you can't, number of hours in the day. But what's really important is to design, whether it's a plane or a car or a boat, is to design in small teams and then to put it out to other groups and delegate. I think at the start, the initial concept come very quickly, in fact, in a small team. And that's really good. That's the best. But once again, when there are errors and things have to be changed, it's difficult when you're small. can a small team win? Can we do it in France? I think there's something that's really a pain in the America's Cup for people who work 320 hours a month or 300 hours a month. It's a bit much, in fact. It's not a criticism of the team. It's like that in every team. I'm more of a socialist at heart. I'm not necessarily against the but there's not necessarily a derogation for the America's Cup, but it makes things more complicated in France, really. I don't have an answer to that question. It's not evident to do a team in France with 169 hours. It's really complicated. We'd have to have a team twice as big, twice as complicated. It's like a snake eating its own tail. It's war economy, yeah. The America's Cup. It's almost a pity that we don't use it. It's really fun to do an object like that. We have to see it like almost like an art, and it's a pity that within this planetary crisis, we can't make groups like this, teams like this that are more useful for the environment, for carbon reduction. There are challenges that we have today that are really important, and it would be really great if we were able to, other teams could inspire from our way of working. A challenge, it's a game, but if they could get inspiration from the way we work with our war architecture with a different purpose. We're talking a lot about technicality there, but in terms of sailing and the sailors, they've been extraordinary in the teams. And the role, I'm thinking of the role of people like Ray Davis, Glenn Ashby, JJ, all of those incredible sailors. There's really a huge resource in our team, was their skill to understand the technical complexities and a horizontal discussion and really easy exchanges. I think that what we saw with previous editions of the America's Cup, what I saw in the French challenge, for example, is the exchanges were more siloed between the design team and the sailors. I think in Team New Zealand, it was like that a long time ago. We kind of opened it up, completely opened it up so that everyone sits together and exchanges. And it's a really horizontal exchange. That was one of the questions, that was, how can you explain the victory of Team New Zealand and over the other teams? Is it a question of the integration of the sailors in the design team? Is it the ability of the departments to talk to each other? Is it really, was this a real desire from the beginning, or is it the culture in New Zealand? It was like that the last time. And a little bit less in 2010, 2013, 14, a little bit less. But in the middle of an America's Cup in San Francisco, in the middle of the edition, we changed our process. Glenn Ashby, Dean Parker came and talked to us a lot. We were really back on the same level, and that was really good. We didn't win though. Dimitri won, in fact, then. Gautier, when we prepared, you underlined this ability to integrate the sailors in the process of the team. Did it? Were you a little bit jealous of that? Yes, I think for us it was a bit, it was one of our weaknesses maybe. When I talk about technique, I include completely the sailors and everybody, because when we talk about technique, it goes from the sailor to the engineer to the guy who builds the boat. Yes, they did better than us, I think, in New Zealand. When we see that they were exceptional sailors on Ineos, there are a lot of Olympic medalists, but we didn't necessarily manage to convert that into. There were discussions, of course. It's not completely siloed, but it was more. They were more positioned in terms of users and pilots than an integral part of the the concept. And I think we talk a lot about simulators, but for me, the simulator is a tool of synergy between the sailors and the technical team, because there's a dynamic, because there's an interface, a human interface that enables sailors to get more involved than just calculations on an Excel sheet or a VPP that can be a little bit complex. I think that's also, we have to understand that in a simulator, we simplify things physically so that this dynamic part can be, which is really, we're not able to resolve today all of the equations. So there's a lot of simplified empirical models in the simulator. So we use other tools like VPP, but the simulator for me is the synergy between all of the stakeholders, and that enables us to have access to energy consumption, for example. We have talked about that, but these are things that are, you know, really right in the heart of the battle. For you, Dimitri, the role that the sailors play, did your design team really talk well to the users? Yes, I found a little bit what Guillaume was saying, because we had a Kiwi in their team last time. Yeah, Parker. So it's a really good test pilot. In fact, it's someone who talked a lot to us in terms of design, used the simulator a lot in the design part, less from the point of view of training for racing, but maybe not as much as with Philippe Presti, for example, and James Petit, but he was very present in the design and the technical dialogue. Really good developer, and his criticisms or his reviews enabled us to into the foils. And did we do it as well as Team New Zealand? Obviously not. But what I see from the outside, Guillaume, is that what hit me when we were doing the preparation is that when I saw the way Team New Zealand was sailing on their boats, I found again the way we sail Peter Burling and like on their 49er. Is it a coincidence in terms of mode of operation? I don't know. Guillaume will say, but from the outside, that's the impression that I had, that their boat really matched well with the type of sailing that
sur d'autres supports, quoi, voilà.
on other boats. So it's all about integration, in fact, and I really agree with Gautier that the question of the simulator is something, and it's an incubator for communication between all of these teams. The simulator itself perhaps is not enough, but the fact that we use it as a catalyst for communication between all of these teams. The sailors can come and use it like a tool which is much more user-friendly now. It's really a big advantage. Last question, we're going over time, but it's really interesting. So, Guillaume, you're only working half time, but what are the lessons for IMOCA and designs, and do you see any other lessons for other sectors, like Formula One, for example, the way it trickles down? Will there be lessons for other racing boats like IMOCA and all teams? This is often a question that is asked, and when we looked at cruising boats, there's not an awful lot of lessons that they've learned, but I'm not saying they're bad cruising boats, but not a lot of links between the two. But in terms of racing boats, yes, there are links, of course, electronics, data acquisition, even people who are working in the teams and the way they work, that get inspiration from that. In sailing, in boats, there's a lot of Dimitri can probably talk about this better than me, but the foils, the profiles, the mechanics. There are a lot of things also that we worked a lot on Gitana and the flap system. It goes in both directions. In fact, it's a mix. We progress in all directions by talking, and not only in one direction. It's a sort of a community that interacts. There's not that many of us talking about these problems. I see that there are questions about the CFD, the quality of, but of course, all of the teams, France, New Zealand, Italy, England, it's always the same people moving from one team to another. It's the same software sellers, suppliers, it's the same mechanics. So of course there's a lot of crossover. In terms of cruising boats, I really don't. There's a lot of people who have cruising boats on foils. I don't know what sort of cruises they're doing. I mean, I can't imagine what foils do in a cruise. I mean, it's not my thing at all. Huh? I'm going to throw my anchor overboard and go on the beach with my kids. I mean, everyone has their own thing, I guess. There's a place for everything. There are applications in terms of motorboats that want foils. Yeah, I guess there's a few things, applications and happening in that direction. Is it good thing? I don't know. I think I'd rather go slower than faster, but I know some people want to go from from the Geneva airport into the other side, the traffic jams, with the consumption of petrol. Gautier, things learned from trickle down from the America's Cup to leisure cruising. Other markets, even we're talking about sailing, but it could be also other markets than leisure sailing. Do you see any trickle down to other markets? Talking about what concerns me directly in terms of sales, what is sure is that in this edition of the America's Cup, we had constraints of weight with very high loads. So it pushed us to think very carefully about new solutions in terms of sail structure. Also, in terms of managing the demand for variable power from the sail plan. So that applies quite directly to a lot of boats like Ultimes and Imocas and other fast boats. And the question of leisure boating, these structures, if we can do lighter sails for sailing, cruising, it's a bit further off, maybe. It's not a direct application, but the support and the format of the America's Cup, it's very leading edge, it's very precise. We are sailing in really controlled conditions. So there are some general things that can be applied to other supports, but we really, it's still in a microcosm of a really constrained sector. But yes, there are applications, I think, even in terms of, we don't think about it, but the definition of the sails and the integration of the finishings, with composites integrated that replace some assemblies. So it could be applied to cruising, to have things that are more aesthetic, perhaps more integrated between the mast and the sail, for example, that to have less human intervention. That could have applications, yes. And we haven't talked necessarily, we don't talk often about the market developing, which is maritime transport. Wind powered maritime transport with wings. So in this context, yes, there are very high loads, so there can be similarities and crossover at that level. I think that could, we could talk a lot about technology transfer from sailing to transport. We do a lot. So Dimitri, I'll let you conclude on this technology of possible transfer of technology. So I'll just add what Guillaume and Gautier said. Concrete elements, for example, could be for racing boats or motorboats. We all have more or less developed autopilots in the various teams, even if they are not authorized. There was an interest or an advantage to have, for American Magic at least, we developed one, and to help sailors to learn to use the boat. And that's a transfer that we see today, either for racing boats or because foiled boats or motorboats with foils, and the integration of autopilots that mean that the user, it's easier, more safer. Also, to contradict a little what Guillaume said, I had a cruise project with my wife in 2010. He said to go as fast as possible from point A to point B so we could be at anchor. So a little cruising boat with a foil, I would have liked that. In fact, there probably be other people in the future would like to go a little bit faster from one island to another, from point A to point B, so that they can take advantage of where they are better. So maybe that will be a development in the future when things will be safer. Of course, that's something that's happened slowly. It's not direct, really. And the America's Cup has always surprised me from that point of view, that there's a lot of no patents get filed, even though we're a really high technology sector. And but we're devoted to this victory and very not frequently looking for, profitability from our sector. External actors maybe can benefit, but rarely the teams that are doing the developing are filing patents. Maybe something that needs to be explored. And
Merci beaucoup, j'ai explosé le timing. Mais
so
c'était très
I'm
intéressant.
very sorry, we've gone way over time, but it was very interesting. I'm sorry, Carol. Thank you for all three of you. I see that Gautier is going off for a sail on Banque Populaire. I can see the mask from here. Thank you, Dimitri and Guillaume. It's time for bed for you guys. Thank you in Auckland. I'll let you finish, Carol. Thank you, Pierre-Yves. It was really very interesting. We had a lot of questions. We're not able to answer all of them, but we'll try and divide up the questions. So we're at the end of our third Visio Café, Euro Large 2021. You will be able to get it on replay on YouTube, the Euro Large Innovation channel. You can continue to follow our news on social media. And you can also sign up for the Bretagne Sailing Valley newsletter. You'll find all the information you need on the sailing page of the website of Bretagne Développement Innovation. So we'll have some more Visio Cafés coming in the future, probably 2 in 2021, and we'll keep you informed of the timing and the program. And if we continue with our English version, we will also invite all of the people who are present today. Thank you very much to everyone, and thank you for your participation. Thank you to our speakers who were really contributed to the quality of this Visio Café. A lot of interesting things. We will be making a report. Have a great day, everyone, and see you soon.
Au revoir.
Merci beaucoup.
À bientôt.
Au revoir.